Hello, this is a short video abstract of our work published in Brain Communications as an open access article. My name is Emil, and over the next few minutes, I'll explain the context and findings of our research. Scalable methods for early detection of Alzheimer's disease is required to identify patients suitable for disease-modifying medications and to improve access to non-pharmacological preventative interventions. And it might be even more important with new treatments coming to the market. In this work, we're particularly interested in story recall, firstly because one of the key domains of early cognitive decline in AD is in episodic memory, which is often measured by a story recall, by manually counting the number of correctly recalled information units. Story recall has been shown to have amyloid-specific cognitive decline in preclinical AD, and also to differentiate between CDR global stable versus progressors. But secondly, we're also interested in story recall for another reason. In another domain of research, discourse and facial research, story recall has been used differently as a way of prompting connected speech, where it's been demonstrated to be the optimal sampling procedure for doing so. And this has led to work using speech and language-based measures to augment performance on neuropsychological tasks such as story recall. It's been shown that people who are amyloid positive but cognitively unimpaired have poor recall of proper nouns and of information presented earlier in the stories, so loss of primacy, and that people with mild cognitive impairment remember the gist of the stories better than the actual words, have poor recall of detail, speak more slowly, etc. And this is all information that's not usually collected or used in the summary scores of neuropsych testing, but can be automatically collected via speech capture. Still, the measures used to date for these speech and language-based features have been relatively simplistic. And we wanted to ask the question, what if we used a state-of-the-art natural language processing model instead? The aim of this work was to investigate whether a fully automated speech-based AI system could detect mild cognitive impairment and amyloid-β positivity that characterizes the early stages of Alzheimer's disease. We used the automated story recall task, a story recall paradigm developed for automatic administration through digital devices using pre-recorded instructions and an automated analysis pipeline. As you see here, instructions and story stimuli are played through a mobile application, and the patient's responses are automatically captured, processed, and transcribed. We then feed these transcripts into the AI system, which is where we used a recently published AI model for evaluating text-pair similarity that goes beyond just simple word matching to produce a vector representation that gives in encoding of both recall and linguistic information. This includes soft matching of words using contextualized word embeddings, repetitions and omissions, ordering, primacy, recency, word specificity, lexical frequency, and other recall and linguistic patterns. We analyzed data from the AMRAPID study, sister studies in the UK and the US, cross-sectional in early stage biomarker-confirmed preclinical prodromal patients. We used a 2x2 cross-sectional design as seen here, recruiting people both with mild cognitive impairment or who were cognitively unimpaired and who were either amyloid positive or amyloid negative. And that allowed us to look at predicting both amyloid biomarkers across the whole sample and within the MCI and cognitively unimpaired subsamples, and then also finally predicting MCI across the full sample. Results are shown here. Going from left to right, these RUC curves show the classification performance of the AI system for predicting amyloid in the full sample, MCI in the full sample, amyloid in the MCI subsample, and amyloid in the cognitively unimpaired subsample. And we compare here against the PLUG5, a sensitive cognitive composite, and also a demographic baseline made out of age, gender, and education level. We saw that the AI system, here shown in blue, was able to predict amyloid positivity both across the full sample, shown in the leftmost column here with an AUC of 0.77, and within the MCI and cognitively unimpaired subsample shown on the right-hand side of the graph here, with AUCs of 0.82 and 0.71. And in all of these cases, outperformed both the PAC5 composite and the graphic baseline. Finally, as shown in the second column here, the AI system was able to predict mild cognitive impairment with an AUC of 0.83 compared to one of 0.89 of the PAC5 composite. So in conclusion, our work demonstrates the feasibility of using a fully automated speech-based AI system for detection of both mild cognitive impairment and amyloid positivity and preclinical AD. And we hope that systems like this will form the basis of more scalable and accessible tools for early detection in clinical care. Thank you for listening.